Welcome to multiple choice question 16 of the 2010 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of a CAS calculator is an efficient way to approach this question. So for question 16 we are asked the gradient of the function f with a domain of all real numbers with a rule f of x equals 5x divided by x squared plus 3 is negative for one of the following options. So if we want the gradient of this graph to be negative, we know that we need the derivative f dashed of x to be less than 0, not equal to 0 because 0 is neither negative or positive. So we need f dashed of x to be less than 0. On the CAS calculator, go into the main menu. Next, we want to bring up the soft keyboard and we want to type in the fraction that was the rule for the function f of x. So that was 5x divided by x squared plus 3. And now what we want to do is calculate the derivative. So we want to go interactive calculation diff and hit OK. And then we wanted to solve when this derivative is less than, so we'll need the math 3 and the inequality symbols here. We want when that is less than 0. So highlighting that, we can go interactive equation inequality solve, and solving for x will give the inequality or the intervals for x where the derivative is less than 0. So we have x is less than negative root 3 and root 3 is less than x, or that's the same as saying x is greater than root 3. So from the CAS calculator, after solving that inequality, we found that x is less than negative root 3, as well as the interval x is greater than root 3 are solutions to that inequality, which means D is the correct option for this question. And from the examiner's report, we can see that 78% of students got this question correct, so it was quite well done by the students in this exam. And you could have also approached this question using a graphical approach or by inspecting the graphs of the functions. So on this first set of axes, we've got the graph of f of x, and we can see that when x is greater than root 3, all of these x values would have tangent lines with negative gradients, as well as all of these points when x is less than negative root 3. As well as inspecting the derivative graph, we can see that the dy dx or f dashed of x graph is beneath the x-axis, so it has a negative value for x is less than negative root 3, and also for when x is greater than root 3. So that made D the correct answer for this question.